What are the limitations of the particle model? Higher content by KayScience.com. The particle model is really good for comparing the different properties of solids, liquids, and gases using these simple diagrams. These circles represent the particles, and the way they're drawn clearly shows us how the particles are arranged, and we can assume how they move as well. So, the particle model allows us to easily compare the properties of solids, liquids, and gases, and this is really useful. Now, when we say particles, what we actually mean is these circles can represent atoms, ions, and/or molecules. However, the particle model assumes these particles are made of solid spheres, and we're now going to learn about how this is a limitation. It's question time. Attempt these questions to check your understanding. In this particle diagram of lithium metal, these circles represent the lithium atoms. Now, this particle diagram assumes these particles are solid spheres. This is what a particle diagram does. They assume the particles are solid spheres. However, we know this isn't the case, as lithium has 3 protons in its nucleus, 4 neutrons in its nucleus, and then 3 electrons in its shells. So a more accurate particle diagram may look something like this, where I'm drawing the nucleus of each of the 9 atoms, represented by the red circles. And then surrounding the nuclei are the shells, where there are 2 electrons in the first shell and 1 electron in the outer shell. So we can see how there is a dense and small nucleus at the center of each atom, electrons in the shells, and then empty space in between the nuclei. We can very clearly see these are not solid spheres, so the particle diagram is not accurate about atoms, and this is a limitation, assuming that all particles are solid spheres. It's question time. Attempt these questions to check your understanding. So atoms of iron can easily be displayed using the particle model, as shown below. So too can molecules of water, shown here. And finally, polymers as well, which means very large molecules, which is why we have a chain of atoms bonded together, as shown here in this diagram. But the problem is, atoms and molecules are different sizes, but all are drawn as the same or similar size and are not solid spheres, as shown in the diagrams above. And this is another limitation, as it's very important to distinguish the difference in size of the atoms and molecules. Because an iron atom is much bigger than an oxygen atom, yet the particle model does not show this. And a polymer is much bigger than a molecule of water, yet the particle model doesn't show the difference in size as well. So we can see how this is a limitation. The final limitation is the particle model assumes the particles have no forces between them. So here we have 2H2O molecules, which are 2 water molecules. These lines between the molecules represent forces between neighboring molecules. So these lines represent how there are forces between atoms, ions, and/or molecules. And what the particle model doesn't show is that these forces distort the shape of molecules when they interact, but this is not shown. So the particle model, assuming there are no forces between the molecules, atoms, or ions, is another limitation. It's question time. Attempt these questions to check your understanding. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.